working on notes number 4, quadratic functions. All right. Warm up. Make a table for the following function and graph it. So we are going to complete the table. That'll come up in a second later, I hope. It's because this is blocking what is going on. And why am I so dark up there? Better? Better. It finally came up a little bit. My problem is when you see the videos, if you ever watch them, the hard thing is trying to get this Elmo so that it will project on the screen so you guys can see it. And this is a separate camera that records this to the video. And so they have to be kind of lined up, and I have to watch all the time to make sure I'm on that screen and this screen. Otherwise, I'm recording and you can't see what I'm doing. Does that make any sense? So sometimes I get like off a little and it causes some issues. All right, so let's try this. Make a table for the following function, graph it. F of x is equal to 2x minus 2. So all we're going to do here is we're going to substitute our values in for x, all right? So we're going to put in here 2 times negative 2 minus 2. And then we're going to do 2 times negative 1 minus 2. 2 times 0 minus 2. 2 times 1 minus 2. 2 times 2 minus 2. Okay, so I just went in and filled it in my process table. So now I need to find my y value or my f of x. Remember, these are interchangeable, but when you're talking about functions, it's going to say f of x. So 2 times negative 2 minus 2 is negative 6. I got 1 negative 6. 2 times negative 1 minus 2 is what? Well, I got 2 times 0 minus 2. 2 times 1 minus 2, 0. 2 times 2 minus 2, 2. So now I've got points. I've got an x and a y value, or a f of x value. Negative 2, negative 6. Negative 1, negative 4. 2, negative 2. 1, I'm sorry, 0, negative 2. How am I bad? I'm so sorry. 1 and 0. And then I have 2 and 2. So I'm going to come over to my graph and plot them. Negative 2, negative 6. Negative 1, negative 4. 0, negative 2. 1 and 0. And 2 and 2. And just to check, I'm going to make sure and draw a line. And if I took a piece of paper along it or a ruler, it would definitely be a straight line. So is this relationship linear? Yes. Explain why. Graph is a straight line. Remember that being linear is different than being direct variation. Linear, it does not have to go through the origin. Direct variation has to be straight and go through the origin. Okay? Everybody good with that? All right, let's move on. Example 1. We're going to be filling in lots of tables today. Okay. It says make a table for the following function and graph it. So 2 times negative 2 squared minus 2. Lots of 2's, isn't it? 2 times negative 1 squared minus 2. 2 times 0 squared minus 2. 2 times 1 squared minus 2. And 2 times 2 squared minus 2. Everybody caught up with me? Okay, so now we're going to figure out the answers to these. 2 times negative 2 squared minus 2, put it in just like you see it with those parentheses and you'll get the answer. What do you got? 6. So what's my pair? Negative 2 and 6.
Wait, you can put them all in at once?
Oh yeah. You're working too hard if you're not. I've got 2 parentheses, negative 1 parentheses squared. You can either use the power up button. Do you guys know that button exists?
Yes.
Okay. Or you could use the x squared button. Either one will work. Minus 2 and hit enter. There it is. You're working too hard. Put it all in at the same time. Okay? All right. So I've got 0. So now this pair is negative 1 and 0. Then I got 2 times 0 squared, which is going to be 0 minus 2 is going to give me, so I got 0 and negative 2. Then I've got 2 times 1 squared, which is going to be what? 2 minus 2, which is going to be, so now I have 1 and 0. Then I have 2 times 2 squared minus 2, which is going to be 6. So then I have 2 and 6. So now I'm going to plot this. I've got negative 2 and 6, negative 1 and 0, 0 and negative 2, 1 and 0, and 2 and 6. And if I connect those, I end up with something called a parabola. Is that a straight line? So is this a linear relationship? No. Explain. It is not a straight line. And I'm going to give you a little more information than is necessary because I want you to have this information. This curved line is a parabola, which we have talked about, and is formed. That's all right. I don't take off for spelling. By a quadratic function. This isn't English class, okay? As long as I know what you're saying, I can figure it out. I'm happy. Okay? I'm going to ask you to do one more thing. When you finish writing that, and I'm going to wait just a second so everybody can get done. Okay. And I'm going to have to say this. I want you to write domain. What is the domain here? Let's think about that. What values of x will make this a function? What values of x will work? Now hold on here a minute. Values of x, okay? This parabola will continue. Do you see how it's narrow down here? And it's widening as you go? It will continue to widen and continue to widen, and it will go, if this graph was big, it'll continue to get wider and wider and wider until infinity, which tells you what is the set of what is this set? The domain on a parabola will always be the set of all real numbers. It's the range that will change. So let's look at the range. Remember I told you to start at the bottom, go here. What is the smallest value the range can be? Y is equal to what? Negative 2. And if this is going to continue to go on and get wider and wider, isn't it going to include everything above negative 2? Yes. So the range is y is greater than or equal to negative 2. Okay? Now, not all parabolas will be opening upward. Okay? If this parabola opened downward, you would take the highest point and you would say y is less than or equal to wherever the highest point is on the graph. Does that make sense? Okay? So sometimes it will be the other way if it opens up towards the bottom of the graph. All right, make a table for the following function and graph it. Y is equal to x squared plus 2. Do you notice that a quadratic has a x squared in it? Okay. That's another way to identify a quadratic versus a linear. A linear will not have a square. Okay. All right, so here we go. Let's take -3, -2, -1, 0, 1, 2, 3. And let's fill in our graph. Now we're going to fill in for our process. So I've got 2 times -3 squared plus 2. 2 times -2 squared plus 2. 2 times -1 squared plus 2. 2 times 0 plus 2. 2 times 1 plus 2. Oh, thank you. 2 times 2 squared plus 2. 2 times 3 squared. Plus 2. Okay? Now we need to put these in our calculator. So what's the first one? Come on. Don't make it one person do all the work. Somebody start at the bottom of the list and somebody else start at the middle. What? Okay, I got a 20 here. So this is a -3 and a 20. I got a 10 here, so that's -2 and 10. 4 is correct. I got a -1 and 4. 2 is correct. I got a 0 and 2. 4 is correct. I got a 1 and a 4. 10 is correct. I got a 2 and a 10. And it is 20. And if you notice, I have a mirror image going to be coming up. Do you notice that 3 is 3 and 20? -3 is -3 and 20. Okay. -2 is -2 and 10. And here is 2 and 10. Okay. It's a mirror image. If I flipped them together, it would lay right on top of each other. So I'm going to graph this. Now, can I graph 20 on this graph? No. But I can get pretty close to 10, can't I? -2, and let's just go up here and say that's 10. Okay? Now I've got -1 and 4, 0 and 2, 1 and 4, and 2 and 10. So something like that. Okay? Is this relationship linear? No.
I said no.
Good. It is not a straight line.
Are we your most quiet class?
Of course you are. You know that. It is a parabola. Therefore, or I use the word thus a lot. It's the same as therefore. I got asked in first period, what does thus mean? It means therefore, kind of. A quadratic function. Okay, here's the big question. What's my domain? The set of all real numbers. And my range is going to be y what? Greater than or equal to 2. Okay. Everybody got that? Okay, I'll hold off for a sec. Ready? Okay. Example 3, real life problems. Suppose you see an eagle flying over a canyon. The eagle is 32 feet above the canyon's edge when it drops a stick from its claws. The force of gravity causes the stick to fall towards Earth. The function h is equal to negative 16t squared plus 32 gives the height of the stick, h, in feet after t seconds. Graph this quadratic function. Okay, so h is representing what? Y, essentially, correct? So I'm going to do this. I'm going to make a process table out of this because they forgot a line. All right? And I've got t is representing my x, isn't it? Okay? So in here, I have 0, which is negative 16 times 0 squared plus 32. 1 is negative 16 times 1 squared plus 32. 2 is negative 16 times 2 squared plus 32. And I'm going to add 2 more down here. Just because I want to show you a little more depth of information. So I am going to put in 0.5. And I'm also, just for general purposes, going to put in 1.5. Okay? Which really, I'm going to make that a negative 1.5. Okay? So, I've got negative 16 times 0.5 squared plus 32. And then we're going to go on the other end and put negative 16 times negative 1.5 squared plus 32. Okay? All right. Here we go. What's the first one? 32. Very good. And remember that this is really my h, which is representing what? What is h representing?
Height.
Height. Okay? And what is t representing? We need, when we're doing real life problems, we need to recognize what our variables are representing because it makes a big difference when we're trying to answer questions. Okay? What's the one when my time is 1 second? 16. My height is 16. When my time is 2 seconds, what is my height? Negative 32. What about when my time is half a second? Okay, 28. All right. And what about when my time is negative 1.5? You get negative 4, actually, right? Correct? Okay. All right. So let's try and graph this. What can we graph? We can graph time at 0 is 32. You just kind of go to an about, okay? Time is 1. I've got 16, so you're going to go to an about. At time 2, can I really graph that? No, because it would be way down here, wouldn't it? How about at a half a second? Can I graph that? Yeah, I could have graphed that. That would have been like 28. It would have been like right here, correct? And at time at 1.5, I'm sorry, we didn't need to do negative. We could have just done regular. 1.5, we would have been what? Negative 4. So somewhere down here, correct? Okay, so I'm going to draw this. And actually, this would probably be like here, so this is a little, okay? All right, let's see what they have to wanting us, okay? They're asking us to use non-negative values. That's why I changed over here to 1.5 because it's not going to matter. Why is the graph only represented in the first quadrant? You realize that that's a first quadrant graph, correct? Have you guys, because first period hadn't been taught, okay? You start here for C for center and you end here. And this is first, second, third, and fourth. Have you guys been taught that?
Yeah.
Okay, because first period acted like I was talking a foreign language, okay? All right, so why does it not include any of the other quadrants in this graph? What? I only need that one because why can't I be down here? If this is representing what? What level is 0 in height?
The floor.
The floor or ground level. Okay? Can I, if it's not on the ocean, I'm not going below the ocean, okay? It said it hit the earth or the ground, right? So if it hits ground level, can I be below ground level? No. And that's why I don't need quadrant 4, okay? I can't have in time. Can I have negative time? So I can't be in quadrant 2. Do you see that? So let's summarize this. Can't have negative time, thus no need for quadrant 2. That's why you have to understand your graphs. You have to look at it and say, what is this telling me? Okay? Can't have negative height in other words, below sea level for this situation. Some situations you can. Situation. Thus, no need for quadrant 4 or 3, really. Okay. Time would, it's still, you can't, you know what, you don't need any other quadrant other than quadrant 1. Is the stick falling at a constant rate of change? What do you think? Look at this graph. What would have to happen for it to be falling at a constant rate of change? What kind of line would you see? A linear, a straight line, correct? Okay, this is not a straight line. In fact, it's getting steeper as time goes on. It starts out kind of curved and then it starts dropping faster. So, no, because the graph does not, or the equation or the graph, the function does not form a straight line. In fact, as the stick falls, it picks up speed. We're going to add a C to this just because I think it's important for us to think a little bit further. And my question would be, when approximately, okay, you can't, I'm not asking for you know, just an approximately does the stick, I can't spell right, hit the ground. Look at your graph. At what point in time is that stick about hitting the ground?
1 1/2.
About 1.5, because it's actually right before that, because at 1.5 we found it's where? Its height is -4, correct? So it's going to have to happen right before that. But 1, it was at 16. So sometime between 1 and 1.5 seconds, that stick is going to hit the ground. Probably closer to 1.5 than 1. Do you see why? Okay, so sometime right before 1.5 seconds. Okay, sometime right before 1.5 seconds. And you know, if you gave me a range of 1 to 1.5 seconds, somewhere in between there, that's fine. This is an approximate. This was not a, at some point you will be able to give me that answer, and we will show you how to get that answer, but today is not that day, okay? We're just looking at this and trying to figure out